there's now research showing that high blood pressure, we can take poo from people with high blood pressure and give it to rats, and they will develop high blood pressure. Conversely, we can take fecal transplant wise, we can take poo from people with normal blood pressure, give it to people with high blood pressure, and their blood pressure will normalize for a period of time. And you never would have thought of high blood pressure being associated with the gut microbiota composition. It is.
Hey there, this is Ari. Welcome back to the Energy Blueprint podcast. With me today is one of the absolute creme de la creme of gut health and microbiome experts in the world. This is someone who is my go-to expert for all things related to the gut and the microbiome. I've had the pleasure of taking one of his courses. He's a professor at multiple universities who teaches on gut health and the microbiome. He's also the head of research at probioticadvisor.com, which is basically an encyclopedic reference and kind of search engine where you can put in either specific strains of probiotics and find all the research on what they're what the scientific evidence has shown those strains to be beneficial for. You can also do it in reverse, where you put in the specific symptom or condition, and it will immediately pump out a whole list of all the specific studies showing what strains of specific bacteria, probiotics, have been shown to be beneficial in the context of treating that symptom or condition. This is an extremely valuable resource, particularly for practitioners. And not enough practitioners and clinicians actually know about this. So part of what I want to do this podcast for is just to help people know this literature more, because having taken a course with Dr. Hawrelak, it's clear to me that there are levels of knowledge around the microbiome and around things like probiotics, and he is just levels above most people in this area. His passion for gastrointestinal health and the microbiome and probiotics was ignited during his final year of undergraduate training in 1999. He went on to do his honors, first class, and PhD degrees in the areas of gastrointestinal microbiota, irritable bowel syndrome, and the clinical applications of pre and probiotics. He's written extensively in the medical literature on these topics, in scientific papers, as well as including 20 clinical textbook chapters. Again, in my opinion, the top 0.0001% of gut health experts out there, absolutely brilliant at what he does, and my personal go-to expert for whenever I have questions about anything related to gut health and the microbiome. So with no further ado, enjoy this wonderful podcast with the brilliant Dr. Jason Hawrelak.
Dr. Hawrelak, welcome. It is such a pleasure to have you. Thank you for taking the time to do this. I think it's very important for people to hear from you and to understand this piece of the puzzle of the importance of the gut microbiome and its relationship really to everything in the body, as more and more research is confirming. But this piece of that story around the connection between the gut and mitochondria in particular is what we're going to be focused on here. So thank you so much for doing this.
You're very welcome. It's lovely to be here, and always great to chat to you too, Ari. And anytime I get a chance to talk about the wonders of the microbiome, I will take it. As someone who's an avid fan in love with the gut microbiome, I'm just really thankful I chose it as a research topic for my PhD back in essentially year 2000. Because I don't know what I'd be doing now if I wasn't doing this, which I'm thankful I am.
So, speaking from personal experience, it's not often that I can say for one of the speakers or people that I'm interviewing that I've actually taken a lengthy course with, but in this case, it's true. I've taken one of your courses on gut health and the microbiome, and I've interviewed many gut health experts over the years, and I can say for everybody listening that Dr. Hawrelak is la creme de la creme. He is really among the best of the best microbiome experts in the world. So what I want to ask of you, given that, is for you to give people a picture of the importance of gut health and the microbiome in overall health. Like how would you go about explaining that from sort of like what's your paradigm for understanding the role of the gut and the microbiome in human health?
Yeah, I mean, I think I'm lucky enough to have been doing this for 20 some years. So it's been interesting seeing the evolution and the amount of research that has bloomed over that time too. And that you go back to when I started writing my thesis on how wonderful the microbiome was, because that was essentially a chapter of my thesis, was looking at, okay, what do we know at that time? And we knew that even from research in the 1950s and 60s was telling us that it was really important for immune system functionality, that if we gave mice or rats megadoses of antibiotics and then locked them in like sterile cages and gave them sterile food, essentially their aspects of the immune system would dip dramatically. Their thymus gland would shrink, their spleen would shrink, their ability of their white blood cells to actually attack invaders would decrease dramatically. The number of secretory IgA producing cells would decrease by 90%. And this is absolutely huge. And then they could essentially expose them to poo. And all of a sudden, the thymus gland would grow again, and the spleen would grow, and the immune system would start functioning normally again. So some of that aspect of it was known, but not really that widely talked about outside sort of probably microbiota researchers. So it's important for gut diseases, and that was what we talked about for a while, like how altered flora could lead to irritable bowel syndrome or inflammatory bowel disease. Those things have been known for a fair while too. Its ability to involved with digestive processes, make vitamin K, make some B vitamins for us. Some of those things were known at that time too. And its capacity to, the ecosystem would protect us against foreign invaders. So if we have exposed to salmonella or giardia, early research found that let's say if we gave a course of antibiotics to some people, and then we could give them salmonella or giardia, and they actually did these studies, typically in prison inmates, I would point out, probably without their consent. But they did these studies and showed that, hey, they could give 1/10 the amount of invading pathogen when there's an ecosystem disruption and get these people sick, and they get sicker for longer. So we knew it was important for that aspect too. But what's been amazing to see is all the stuff that's come out around actually, microbiome and how our nervous system is working, how our brain is functioning, how our mitochondria work, how we age, our level of inflammation in our body. And I think that it's been that shift from, here are some microbes that probably aren't that important in the gut that we can just kill with antibiotics, that they don't matter, to actually know these are important. Maybe we should start thinking of these microbes like a microbe organ. Like we start, like back in the early 2000s, there were people talking about this is the microbe organ. We have to start taking it seriously. It's really important. We can't just be like killing it willy-nilly with different interventions and not think it has consequences, and consequences are much greater than that. But I think even what's shifted in the last 20 years is that conception has gone from, here's an important organ in the body, like the liver, to actually you are a being that's made out of microbe cells and non-microbe cells. And we are still debating what the ratio of that might be. We've got 100 trillion bacteria in our guts, and some people would argue that's like we're 90% bacteria. Other people would argue we're 2/3 bacteria, 1/3 not bacteria. But either way, we are mostly bacteria, and what they do for us is super important and integral to what makes us human, and how everything else works. And I think what you alluded to before is correct. Is that every single year that comes out, we're going, this is connected to the gut flora. This is connected to the microbiota. This is connected to the microbiota. That is what's been fascinating the last 20 years. I mean, you go back to, there's one pivotal paper published in, I think it's 2006, where it was the first one that showed that kind of what we could do. Essentially, we could pass on obesity. The amazing study, because they essentially took poo from obese rats and gave it to these little, thin rats, and they essentially went obese. Despite no change in caloric input or caloric outputs. They weren't exercising less, they weren't eating more. Essentially, it was the change of the microbiota. It was all it took to induce substantial obesity in these animals. And I think that was the paper that really shifted people's brains. Like, oh my God, it's not just gut. It's actually, we can influence things like that. Who knows what others, we can influence anything really. And I think that's what's coming out of it too, because there's now research showing that high blood pressure, we can take poo from people with high blood pressure and give it to rats, and they will develop high blood pressure. Conversely, we can take fecal transplant wise, we can take poo from people with normal blood pressure, give it to people with high blood pressure, and their blood pressure will normalize for a period of time. And you never would have thought of high blood pressure being associated with the gut microbiota composition. It is, as well as things like depression and anxiety and obesity and type 2 diabetes, like a number of different conditions now that we're, and more than that too. You need like heart disease has a cancer, and other precancerous conditions often have a microbiota component too. And even more fascinating, I think, in some respects, is there's now research showing that people who have certain ecosystem compositions will respond differently to cancer, like treatments like chemotherapy or radiotherapy. If you have a certain microbiota picture, you have a much better outcome. And it's only been the last 12 months that I've actually started working with cancer patients to optimize the microbiota to get the best outcomes for their conventional cancer treatments. And, you know, again, that would not have been something that was on anybody's radar, you know, even 5 or 10 years ago. So that aspect has been absolutely amazing to see.
I have a broad question for you. I spoke with another gut specialist friend of mine, Dr. Vincent Pedre. I don't know if you're familiar with his work. He just came out with a new book called, I think, the Gut Smart Protocol. And several months ago, I think for the process of writing the book, he traveled to Tanzania, to Africa, to see the Hadza tribe, and they did some microbiome testing of some of the members of the tribe there, and they found some interesting and surprising results. I know one of the things that's sort of previously known from those kinds of studies was enormous amounts of diversity of microbes, along with many species that are, you know, considered pathogenic, but in that context don't seem to cause any problems. But he also said, and I believe I'm getting this right, I think he said that there was almost no bifidobacteria, or maybe actually no presence of bifidobacteria in the microbiomes of that population. Have you heard anything like that? Does that make any sense to you? And the reason I bring this up is to ask the question, on a scale of 1 to 10, what do you think is our overall understanding of the microbiome? Like, how completely do you think we understand this? Maybe as a bit of context, I think there's a famous quote from like 1920 or 1930, somebody who was a clerk in the US Patent Office, and who pronounced in 1930, all things that have been invented, that can be invented, have already been invented. You know, we're done. We've figured everything. You know, there will be no more inventions from here. We understand everything. We've invented all possible things. And kind of understanding the role of human hubris. Do you think we're in the infancy, in the adolescence and the teenage years of understanding the microbiome, or do you think we've got it all figured out? Where would you sort of grade our current understanding?
Definitely not all figured out. No, I don't think we're in infancy either. I think probably adolescence, I think, might be the better way of describing it. And I think it also depends when you've come into this too, because I will hear people that maybe newcomers is the wrong term, but people that knew nothing about the microbiome until like a couple of years ago, then it's like, oh, everyone's talking about the microbiome. I'm going to start looking at it. And then you see those people who often go, oh, we're in infancy, we don't know anything yet. Right. And it's like, well, for them, it's true. they don't, because they've only spent a couple of years, like, you know, looking a little bit at browsing at the edges. But I would say that people that have spent 20, 30 plus years looking at the stuff, we go, no, actually, we know a fair bit. And we're always learning more. There's certainly enough here to actually implement and change people's lives. And I think that's probably the more pivotal point, because there'll be some of those people who are, you know, browsing at the slides and this is all new to them. We're like, oh, we don't know enough. We can't change it. They tell people to do anything yet with the information we've got. I'm like, I want them, people are missing out on optimal health and continuing with disease states for thinking like that. To me, is huge, because as a clinician too, I mean, I'm a research scientist, I'm a clinician educator. I mean, I actually have a chance to work with patients and implement things that you come up through the research going, oh, okay, well, discussion around how we can encourage, well, let's say B-rate production through the supplementation of something like partially hydrolyzed guar gum. You know, reading that, you know, in 2015, I came across some research around that. So, okay, let's start trialing this thing on patients, and you just start seeing it works. You change someone's microbiome composition, and you can change almost everything. And it's not always like super quick, and it's not always like this straightforward like line of like here to there. It can be a bumpy journey, but I'm just always amazed at how much we can change, you know, from energy levels to cognitive capacity to you know, pretty significant disease states like Crohn's disease or also colitis, which, you know, associated with like, you know, blood and diarrhea and mucus, like quite a level of inflammation. But here we can change the microbiota composition, and boom, that stops. And yeah, and I think it's because I just see it work on a weekly basis with patients, that microbiota modification and optimization changes lives and changes the process. There are so many different disease states. So I can't understand or even take remotely seriously the people who say we can't do anything yet, we don't know enough, because it's like, yeah, we do. Does it mean that what I do 15 years ago is what I do now? No, because we're always learning, and we should be learning and changing things and evolving as the research evolves and our clinical experience evolves too. It's we get better at doing what we're doing and modifying things. We have better tools now to assess the microbiota than we did before. But I mean, going back to the bifidobacterial one, you're right. There were some other research scientists years ago showing that the adult Hadza don't seem to have bifidobacteria. Interestingly enough, it's still in the babies. The ones who are breastfed do have bifidobacteria. So it's obviously there in low amounts, because otherwise it can't get passed on to next generation. It just doesn't seem as though the diet of the Hadza, even though it is a immensely rich in fiber, it's like 100, 150 different grams of fiber per day on average, I believe. Is particularly good at nurturing bifidobacteria, but it does nurture a hell of a lot of different bacterial species, more than what we have, a lot more. And it might be that there's just so much more competition for, plant compounds in that gut, so it gets split over a wider thing. And for whatever reason, bifidobacteria aren't dominant, but they are there in the breastfed infants. So we know that they are still playing that key role in that time point in which arguably the immune system is being trained on how to function properly is in that early window, and having high bifidobacteria is immensely important at that time window. And there's still, I do think in Western populations, it is an immensely important microbe to have, and in a more optimal level. And there are people where it can be very clear, you bump up bifidobacteria and a bunch of things tend to fall into place health-wise for them. But it may not be the case for Hadza. I would argue that it's a key integral component of the adult ecosystem, although I would say that if you started giving those kids formula instead of breast milk and you didn't feed bifidobacteria, there's going to be a lot of consequences to how that population and disease states that they develop as a consequence of that.
And just to clarify for the listener, the reason that I asked this question is because we have so much sort of modern scientific literature that's emphasizing the importance of bifidobacteria species in the microbiome. And then we went out and found, this population of humans that has very healthy guts and doesn't have most, or maybe you could say even all or close to all of the gut problems that are typical of Western populations. And yet they don't have a predominance of this bifidobacteria species that are very emphasized in the literature as being important. So kind of gets at this question of, well, how much do we really know? Are we, you mentioned breast formula there. When my wife was born in Chile in the 1970s, all the doctors at that time were telling new mothers, don't breastfeed your infants, because we've through our science, we've got it all figured out, and according to the science, we've perfected what babies really need for nutrition, and our very sciencey formula. Baby formula is much healthier and much better for your baby than breastfeeding them, which is very primitive, and and that sort of thing. And of course, we know now that this was very, very much based on hubris and ignorance, and that we're very, very wrong when we think that we're smarter than nature. Most of the time, I would say.
I concur.
Yeah.
Yes. Yeah. And that wasn't just Chile. I grew up in the 1970s in Canada, and the doctors were saying the same thing. So I was never given any breast milk for that reason too. It's like, wow, formula's so much better.
Right.
Like, no.
Okay. So here's another dimension to this question that I think is important. After taking your course, out of curiosity, I decided to do my own microbiome testing, and I've shared the results with you. And what was interesting is, because I know that not all tests are that accurate or valid or reproducible.
Yeah.
The practitioner who was ordering the test for me said, let's do this test. This is the test I like. I said, okay, fine. But I also want to order this other one because I want to cross-check it so we can validate whatever things show up. I want to validate with another test with a different technology to see if it's also showing the same patterns. And as you know, those two tests produced very different results. And so then you said, hey, based on this, we can't really draw firm conclusions. Let's do another test, a test that you really like. And we did that test. And then we had now 3 microbiome tests. and there were still some patterns that were hard to discern, and certain things that were in one test I'm super high on butyrate, another test I'm very low, another test says I'm very high in bifidobacteria, another test says very low. I mean, there were things that were very off. So again, speaking to this question of kind of whether we're in the infancy or the adolescence or the adult years of our understanding of the microbiome, looking at this dimension of microbiome testing, and now all the different testing technologies that are out there, and things like, for example, Viome, Ubiome and Viome, where they're saying we've got this, the microbiome holds the future to understanding your risk of various diseases. And they'll test your microbiome and say, I've seen the results of some of these things that they give to people, and they say, based on your microbiome, you shouldn't eat broccoli, and you should, like, literally, you shouldn't eat broccoli. And you should eat these foods and not this food and this food and that food. And, avocados and broccoli are foods that you should avoid, for example. Okay, I won't give any further context, but what do you think of this realm of testing and how much a lot of it appears very sciencey? What should people know about this realm of microbiome testing?
I would say that some of those specifics around diet, I can't imagine they're all that super evidence-based. Yeah, as someone who's been in this field for ages, and I look for microbiome food interactions all the time, because we're changing microbiomes through dietary means is one of the main techniques we're using to do so. That getting into specifics like that, I think, is beyond where we're currently at. And I think they're probably just using sort of computer algorithms to help postulate things based on some known biochemical pathways from bacterial species, because there are tests which Viome uses, like shotgun metagenomic sequencing, which is arguably the best way of assessing the microbiota composition in its entirety, because we can look at all the different DNA that's there, and we can look at all the bacteria, we can look at protozoa, we can look at fungi. I still think the tests are a little bit limited in their fungal libraries at the moment to tell us too much about that, but eventually that'll catch up on board. They can look at viruses, and they can look at genetic pathways of those bacteria in the gut. And I think there's a lot of useful information that comes from that, and I think they're very useful tests. But I do think that they might be extrapolating, in my opinion, too much those pathways to lead to advice like that. I do think that it can be helpful to help guide practice, and I think we can get listen, it's a good question around the tests. Yeah. And I think the challenge here is like, what's real almost is what it comes down to, because we used to think culturing, where we would take poo samples out and we grow them in petri dishes, was gave us the true representation of what was there. Does it? Because it depends what we grow it on. Like, if we try to grow that bifidobacteria on one type of media, it grows really well and grows really prolifically. Another media, it won't grow at all. Another media will grow a little bit. And it's like, have we chosen the right media to accurately represent what's there? We don't know. That's just what we've done, and we're making assumptions around that. And then now we're looking at the proportion of DNA, which I think is a much better idea around context. Going, okay, well, how much bacterial DNA is there? What does it belong to? And we get this proportional representation of what's there. So we go, okay, well, it's 2% bifidobacteria and 20% Bacteroides, and we can piece it together that way. And to me, that I think it's a much better idea, or gives a much better accurate representation of what the ecosystem actually is like. And then we have tests that are like PCR based, which are also using DNA bits. So I think much more accurate than the old culturing type approach. But but sometimes they try to quantify things too. And I just know clinically that I've just seen results which just seem a bit bizarre on some of those quantitative PCR microbiome tests. So, and they're not used that much in the research world. I mean, really, the vast majority of studies that are trying to define the microbiome, expand our knowledge and understanding of the microbiome and what it does, is using shotgun metagenomic sequencing or 16S rRNA, which is also a DNA-based thing that gives us a picture of its entirety. I think what we have to do, though, is try to stick within ecosystems from testing, because if you compare up 16S with a shotgun, the percentages for some things will match up, other things will not so much. But if you've been looking at enough of them, you can still get an idea, okay, what's a normal level of bifidobacteria on a 16S versus a normal level on a shotgun. So you can kind of see whether people are higher or lower. But I think it's important to stay to really just compare within that ecosystem it gets more tricky when you start comparing between different test types, as you saw. And I experienced too the same thing when I sent five, still some out to 6 different labs, and the results you got them were just like so different in so many ways. But some things thankfully were consistent, like some functional marker, like digestive markers, inflammatory markers were thankfully consistent. But in terms of microbiota composition, that differed a lot. And I use culturing labs, I use PCR labs, and I used them a DNA-based one too for my experiment.
Mm-hmm. And I just want to point out that there's a broader principle here that applies beyond the microbiome, that a lot of tests, like I think people in the general population assume, hey, if the test exists, it must have lots of research validating it, supporting that it's accurate, that it's valid, that the results are reproducible. And I just want to point out to listeners, there are many that the tests are coming from private for-profit companies. There is an industry there. They are in pursuit of creating new products, meaning new tests to bring to market constantly that help make them money, and that those financial incentives often drive new tests entering the market that aren't necessarily valid or accurate or meaningful data or even reproducible, meaning do the same test twice, you get totally different results. And that issue is pervasive across a lot of testing, not only microbiome testing.
Yeah, no, I fully concur. And it is always amazing seeing some of the tests that are offered in the sort of functional medicine field that have never been validated against any sort of gold standard. And we know that's kind of basic. That's what we're after. Does it work at least as well as our current tests are too?
Right. And with that, and this is really meaningful to understand, because let's say in my case, I did just the one test this practitioner wanted to order for me. Based on that test, there were certain things present that the practitioner was saying, well, let's do this supplement that's an antimicrobial supplement to cleanse your microbiome and get rid of these bad bacterial species. But then I did another test that didn't show the same abnormalities as the first one showed that he wanted to treat me for. So these are differences that are very consequential. And I highly recommend people cross-check results or use really smart, high integrity, trusted practitioners who really know what they're doing as far as accuracy of tests. Okay, so looping back to the first thing, the connection of gut health and the microbiome to health more broadly. We know we've got, as you said, there's like all these emerging layers to the story constantly: the gut-brain axis, the gut-skin axis, the gut-immune axis, the gut-lung axis, the gut-liver axis, on and on and on. And of course, we know there's a gut-mitochondria axis. So what's the connection between the gut and mitochondria?
Yeah, and this is one of those newer areas, and I think we're getting greater clarity all the time. And if we ask this question 5 years from now, we'll have so much more understanding, because I really think it's probably only been the last 10 years that people have even thought of this at all. Because again, people really just thought what was in the gut was in the gut. But I think now we're looking at, I think that to me, the mitochondria microbiota axis is mediated for a few different things, and looking at primarily bacterial metabolites. And I think it can be beneficially modified by things like the production of butyrate, for example, which is a short-chain fatty acid, and also some polyphenol transformation products, and then also detrimentally impacted by things like the release of endotoxin in the gut. So to me, those are probably the three main ways in which the microbiota can modify what our systemically found mitochondria are actually doing and how they function.
So let's talk about the lipopolysaccharide aspect of the story. So what are they, first of all, and how are they getting into mitochondria where they're causing damage at that level?
Yeah, so lipopolysaccharide, I might just say LPS for short, also known as endotoxin, which I think people might connect a bit better with. Okay, it's something that causes a toxin. But interestingly enough, it's not grown by the bacteria as a toxin. There are bacterial toxins called exotoxins that the bacteria are releasing intentionally to make you unwell or to do some sort of targeted thing. Endotoxin, some bacteria in your gut grow, just like we grow nails, we grow hair, it grows endotoxin. And these bacteria are called gram-negative bacteria. And most people will be familiar, at least vaguely, with gram-positive, gram-negative. Gram-negative means they just don't take on a stain, a colored stain invented by a guy called Gram. That's essentially what it was. He stained things, something took it out, some that didn't. And the ones that didn't essentially have lipopolysaccharide in their cell wall. And it can make up about 80% of the cell wall. So a lot of that is LPS. It just turns out that this stuff is immensely pro-inflammatory. We know it can actually damage the gut lining itself and cause like a leaky gut. We know when it reaches systemic circulation, it actually causes inflammation everywhere. We know it can impact negatively blood sugar regulation and insulin sensitivity. It damages the blood-brain barrier. We know it can change what neurotransmitters our brain produces because of neurological inflammation induced. And we know it's a key driver of neurodegenerative conditions like Alzheimer's and cognitive decline. That's really come to the fore recently. And they can do autopsies of people with Alzheimer's brains, and it's full of LPS compared to the healthy controls of the same age. It's like really pivotal. What's interesting though is that people's the amount of LPS containing bacteria in the gut dramatically differs per person, depending on the composition of their ecosystem. So, and even within that, there are really pro-inflammatory types of LPS and less inflammatory. So let's focus primarily on the pro-inflammatory sort that we get from a group of bacteria we call proteobacteria. And people may not know that term, but they will have heard of E. coli before, or probably Salmonella, or Shigella, or Campylobacter, Helicobacter,
I think you lost
Klebsiella.
people after E. coli and Salmonella.
Okay, I might have. Those are all proteobacteria anyway. So you kind of know some of the more familiar ones. Those ones, their endotoxin is just immensely pro-inflammatory, immensely so. And then we have other bacteria that some people may have heard of called like Bacteroides or Allostipes, who are also gram-negative. They have lipopolysaccharide, but it's maybe 100th or 1,000th as potent as an inflammatory agent. So we're going to focus on the proteobacteria. Now, as I was saying, it differs how much is in people's guts. Typical for a Westerner is like 4-5%. It's far less in a lot of traditional cultures and people eating, I would say, more fiber enhanced plant-rich diets. But you get some patients that I've seen it at 50%, 55% of the ecosystem, and I've seen it 0.2% to give sort of a spectrum of what that can be. And that difference is dramatic. So in terms of the amount of this pro-inflammatory compound that's being released. So again, it's not releasing it intentionally, it's just dying. Bacteria are constantly living and dying. So when they're dying, that endotoxin is released in your gut. And your body can deal with a bit of endotoxin. It's fine. Your intestinal cells would detoxify it. Then it gets to your bloodstream, your liver will detoxify it, and you get very little. Generally, if you're eating really well, and your gut integrity is good, your bowel transit time is good, your ecosystem composition is good, you get very little endotoxin floating out in your bloodstream. But that's just not the reality of Western life. We generally have poor integrity. We're ingesting lots of alcohol. We're taking non-steroidal anti-inflammatory medications for pain relief. And we know like alcohol and NSAIDs cause gut leakiness. And we know that other aspects of our diet and lifestyle might cause gut leakiness too. So we get more of that endotoxin coming in. But that Western diet and lifestyle also leads to essentially increased numbers of negative proteobacteria in our gut, increased proportion. So you get this combination of a lot of endotoxin being released in the gut. You've got a leaky or small bowel. But typically for Westerners too, they have a slow transit time. So that essentially means that endotoxin, rather than being pooed out, 12 hours later, is maybe, if you're lucky, pooed out 2, 3, 4, 5, 6+ days later. And the problem is not really much is pooed out by then because it's absorbed. It doesn't just sit there. It will be absorbed and get into your bloodstream. And as I said before, your liver can deal with a little bit of it, but you get above that point, it goes beyond that. And we know that the LPS is the main driver of liver damage in alcoholics. LPS is the main driver of liver damage in fatty liver. It's the LPS from bacteria that cause the damage. So it can directly damage that. And we know that it works essentially as a mitochondrial poison. It can actually cause mitochondrial inflammation and mitochondrial dysfunction. And it's doing that in the liver, and it's doing that everywhere in your system, including in your sort of neurological system too, and hence leads to all these degenerative nervous system conditions that we're seeing more and more commonly in Western nations.
And for anybody listening, I would encourage you to spend a little time going on PubMed or Google Scholar and just typing in endotoxemia and any disease you can think of. And there's probably some research on it. There's research on it linked with chronic fatigue syndrome and fibromyalgia, linked with neurodegenerative diseases, linked with heart disease, linked with diabetes, linked with obesity, non-alcoholic fatty liver disease, on and on and on. I mean, pretty much any chronic disease of civilization, which is 80% of the disease burden, is going to have a link there. There's one other layer to this that I want to emphasize. I think there's a tendency for people to think that there are certain things that cause leaky gut. It's like when I take antibiotics, or when I take alcohol, or when I do this thing, then I'm causing leaky gut. And then, or I do this combination of things and I have leaky gut. This layer to the story that you're talking about here is the ecosystem of microbes themselves that's in the gut. If there is a big imbalance in the direction, a shift in the direction towards a predominance of these gram-negative bacteria, and especially as you emphasize the slow bowel transit time, if you don't poo very often, basically, and I know that's not totally accurate to measure bowel transit time, but people who are maybe taking one poo every 3 days or something like that. But the presence of these bacteria themselves are producing this endotoxin that is itself driving gut permeability and leaky gut.
Yeah, very much so. And even I've recently been looking into the celiac disease literature too, and it's now being linked to, it's not just gluten, it's gluten with lots of proteobacteria that's tending to result in the gut damage and it seems to be a core prerequisite for celiac disease to develop in people with the right genetics. It's not just eating gluten. It's not actually, you need to have a dysbiotic small bowel ecosystem with these proteobacteria present, which leads to the gut damage, and then boom, celiac that develops. So yes, it is really a key thing that the composition of the gut and remembering that it's that balance level of proteobacteria that will determine, and then I would say even in those other conditions like alcohol-induced damage, we know that. And even we can look at non-steroidal anti-inflammatories like ibuprofen. We know, okay, yes, these cause gut damage, but they don't cause gut damage in germ-free mice and rats. So if you've got mice and rats with no bacteria present in their guts, you can mega dose them of NSAIDs and they no gut damage.
Wow.
Yeah. But if they have gram-negative bacteria there, you can give them a tiny dose and they get severe damage. Wow. So it is, even this agent we see as being gut damaging, it's still mediated a lot through the microbiota too.
So you could think of that almost as like the resilience of the gut to insults, to chemical or environmental insults, stresses.
Yeah.
The ecosystem itself is going to influence whether a particular insult, whether it be alcohol or NSAIDs or gluten or something like that, is going to cause gut permeability or not.
Yes. Which I think is fascinating, and I think you're right. It's not on people's radar. That is that, and it's just a huge thing. And I think even again, I've been looking at the research on SIBO literature too, and even that thinking of being too much bacteria growing in the small bowel is actually changing to being the wrong types of bacteria overgrowing in the small bowel. And again, it's coming to mostly around proteobacteria.
So you feel that's a shift in the thinking, the paradigm around SIBO.
Yeah, I don't know if it's filtered out yet, but I think if you start looking at the research around it, it seems like, okay, you can have higher levels of some bacteria and it doesn't seem to be problematic, but this definitely seems to be associated with symptoms and gut damage when you have more gram-negative bacteria being present. And it's around diversity, and also explains why there was a study where they gave fecal transplant in capsule form to treat SIBO, and they had amazingly successful rates of treating SIBO for like 6 months afterwards. Cured, and the vast majority of people of giving a fecal transplant via capsule. And their thinking was let's change. We know that the ecosystem in the small bowel, people with SIBO, is less diverse and there's more proteobacteria. Let's see if we can introduce more diversity in a healthy ecosystem. And one study so far, but I think it was just pivotal in shifting people's thinking about the condition, or starting to anyway. Very
interesting. Okay, so there's a couple other layers to the story of the gut mitochondria connection that you mentioned. And you go where you want to take this. There's, as we talked about before we started recording, there's the ellagic acid and urolithin A part of the story. There's the polyamines part of the story, and then there's the short chain fatty acids. So tell us what kind of some of the other layers of the gut mitochondria connection.
Yeah, and I think butyrate makes sense to go to next, because I think this is a key thing. And it's one of the things that our ecosystem can make for us. I think this is also pivotal to know too, that and maybe it's just stepping back to short chain fatty acids. What are they? So when we consume foods, predominantly fibers, but even I would say to some degree, protein, aceous foods too, we produce these things called or bacteria ferment them or putrefy them, depending on whether it's protein or fiber carbohydrate compounds, to short chain fatty acids, predominantly as the main end product. Yeah. And there's three main ones. There's acetate, there's propionate, and then there's butyrate. Majority of people, it's mostly acetate that they produce, and a relative difference in proportion of propionate and butyrate. And some people don't make much butyrate at all. And there's a couple of factors that can determine that. One, the levels of butyrate producing bacteria you have in your gut, and two, what you eat. And that probably is the pivotal thing that determines number one anyway, for the most part. And again, looking at what proportion of your ecosystem might be composed of butyrate producing species, the lowest I've seen is none, absolutely zero, which is someone who's been on long-term antibiotic that called vancomycin, where it just completely, there was just no growth, to 70% of their ecosystem being composed of butyrate producing bacteria, which is probably the far extreme end of that. Most people would fit in that sort of 10 to 25% sort of mark. And I think this group of bacteria is starting to get more acknowledgement, but I think in terms of what names that people will be familiar with, probably not so much, because we're talking about, like, I think one of the key ones is Faecalibacterium prosnitzii, which is starting to get a bit of a name out in the outside research circles or medical circles. But there's other ones like Roseburia and Eubacterium and Staphylogranular and Anaerostipes and Cystinibacter, Ruminococci that most people are, know nothing, have never heard of them before, and have no idea that they're actually really important. You should really focus on feeding these guys, because you've got the capacity to have these amazing butyrate producing factories in your gut that are just either they're functioning and working for you, or they're like sitting idle. And it kind of depends on what you're feeding. And luckily, we can feed them up too. That might only be at 2% now or 10%, but a lot of work I'm doing with patients is, okay, let's go from that 10% up to 40%. So you're actually increasing the proportion fourfold, increasing the amount of butyrate produced fourfold. So butyrate is an amazing substance. Yeah, so we know it's immensely important for your intestinal integrity. So if you want to protect yourself against leaky colon, leaky small bowel, is ensuring that you're having enough butyrate being produced. It makes up, I think, 70% of the energy needs of your colon cells is from butyrate. So if you don't make enough butyrate, your colon cells don't function properly and don't regenerate properly. And that also puts perspective on it too, because if you're only making a small amount of butyrate, every little bit of that is being consumed essentially by your colon cells. You have to produce enough to feed your colon cells and more, so you can actually get some into your circulation, where you start getting the systemic benefits of butyrate. And this is where it's helpful for mitochondrial support.
So that the bucket is overflowing enough. There's excess after the colonocytes have used their portion. Now it's the bucket's overflowing, and now you've got this butyrate going into the bloodstream, where it can reach the brain and reach the mitochondria throughout the body.
That's right. Because if you don't get that, and if you don't have enough, you just have enough to feed your colon cells, you don't get the systemic benefits that we're after for mitochondrial support.
So what does it do?
Enough.
What does it do once it reaches the mitochondria and the brain systemically?
Well, we know it can actually help heal the blood-brain barrier, and it actually can decrease neurological inflammation. And I just remember in 2016, a paper in a mainstream neurology journal talking about eating a high fiber diet for brain health. And it was just like, it was just mind-blowing, because that would not have been something that was discussed 10 years ago, even, let alone longer in the past. No one would have any connection of neurological conditions and gut or eating fiber, because I was like, let's eat more fiber to feed butyrate producing species. It was just great to see that sort of content out there, because we know its capacity to decrease neurological inflammation, help regenerate neurogenesis, brain-derived neurotraffic factor is upregulated with butyrate. It improves insulin sensitivity, so it actually improves blood sugar regulation as well, but it also improves mitochondrial function. It reduces, I think it enhances its capacity to generate ATP, enhances mitochondrial biogenesis, and it can actually reduce the amount of reactive oxygen species that are developed as well. So you've got this amazing thing that your gut can produce for you if you can nurture those species and encourage them to make butyrate for you.
Mm-hmm. Fascinating.
And I love that. Yeah.
There's an interesting layer of the story that Dr. Vincent Pedra mentioned to me about the Hadza as well. He said that they found, I hope I get this right, but I'm pretty sure he said that they found not such high butyrate levels, but they found very high propionate levels. And
interesting.
I think that they speculated that it has to do with, either the amount of fasting they do, or I think especially the amount, this is what it was the amount of activity, physical activity that they do. And they found that for some reason, I don't know the biochemistry, but propionate was particularly beneficial for them as they're out, on a hunt all day, as compared to high butyrate levels. So, something to that effect. Maybe it's used, I think it's that it's used in energetic pathways more efficiently, like to help support high levels of physiological or physical activity, or to suppress hunger, or something to that effect.
Yeah, interesting. Yeah, okay. I mean, I know a bit about propionate too, but not a huge amount of. In terms of, I know that really high levels can be neurologically toxic because, the models they use are animal models where they kind of inject propionate into the brain, and they go, oh look, they start developing autism-like behavior. So it's a bit of a false model. But I have had kids on the spectrum that I've worked with that have had really high propionate producing species in their gut, and it has been an issue for them. And you can decrease propionate levels, and it's actually improved cognitive capacity and awareness, and the kids are more present in here and now. So I think that it can be problematic in large amounts, but I don't think they had in that kind of quantity of propionate producing bacteria in their gut.
Mm-hmm. Yeah. Okay, so before we get to practical stuff, can you tell us a little bit about the urolithin A aspect of the story and how that relates to the gut mitochondria connection?
Yeah, and maybe we can take it a step further back, just around polyphenols first. And polyphenols are the brightly colored compounds we found in plant foods, natural foods, not the red food dye or blue food dyes that you can buy in processed foods, but blueberries, eggplants, raspberries, red rice, black rice. Those compounds, polyphenols, are found pretty ubiquitous amongst the plant foods of vegetables, grains, whole grains, vegetables, fruits, legumes, nuts, seeds. All in their whole form have got a varying amount and type of polyphenols. The interesting thing about the polyphenols is 90 to 95% are completely indigestible and unabsorbable to us. So they're there. And if you didn't have the gut bacteria and the right gut bacteria, we just poo them straight out, and they would do nothing for us because they're too big. The molecules are too big that we can't digest them. We don't have digestive enzymes to deal with them, but our gut bacteria do. Yeah, and they're really important for this conversion of these polyphenols into smaller molecules, which we then absorb. And in that process, they get food from it. So it's like a win-win situation. So we're eating the polyphenols from blueberries, which taste good to us. That's a win. Those polyphenols reach the colon. Well, let's use pomegranate. Let's say pomegranate as a food, delicious food, full of specific polyphenols called elagitannins. Elagitannins aren't broken down by us. They're too big to be absorbed by us. Even if they were in our bloodstream, we go, oh, it's an antioxidant, it's great, but we can't get it because it's too big. Reaches the colon, and there it gets actually impacted by gut bacteria, and they convert that elagitannin, they eat it and break it down to something else. They get energy, so their populations increase, but they release a breakdown product, which then is therapeutically active and absorbable. Yeah, and we know that all these sort of plant foods that have these polyphenols were often entirely dependent on this microbiota conversion to get the health benefit of it. Yeah, and I think that's fascinating too. But the one in specific with the elagitannins in pomegranate, you also get them in, I think it's walnuts and pecans too.
Chestnuts. I looked at a study to find the foods richest in it.
Okay,
it was water chestnuts or something like that. It's yeah. The big ones that are soft, I'm pretty sure they're called chestnuts.
The ones that they tend to roast. Like I always think of those old English stories about roasting chestnuts for Christmas time, sort of. Yes, because they've got a very brown husk on them. I reckon that's probably high in that particular polyphenol. That would make sense.
Yes. So it's interesting. I always hear people talk about pomegranate. Nobody mentions chestnut, but chestnut is actually, I think, even slightly richer than pomegranate.
Interesting. Okay. I think I love pomegranate because I'm a herbalist, and I use pomegranate. The husk, the skin, which is actually much higher, I must say, in elagitannins than the fruit anyway. So if you're after a really hefty dose, the skin would give you a hell of a lot more.
You eat the full peel with it?
Yeah.
Really?
Yeah. I mean, it doesn't taste good. So I mean, I think the idea of just sitting down and just chewing on a whole is like not remotely appealing. I mean, I've made a pomegranate husk tincture for years, but now you can buy it in powder form, and probably in not too distant future, there'll be capsules with it too, because some company will be like, there's actually more elagitannins in the skin than there is the fruit, but it's not particularly tasty. So, I have patients who mix it in their smoothies and with other things, and it can be masked over okay, but just like chewing on it is just not an option that you're going to enjoy. It's really, really strong tasting, but it's much higher in that compound. Yeah.
Do you think these polyphenols and flavonoids and things should be put in the category of prebiotics? I know they're not generally considered to be that, but based on the mechanism you just described, it sounds like they essentially are.
Yeah, it probably depends a bit on how narrowly we define the term prebiotic. Yeah, and I would probably put them in more into the colonic food type category, that it feeds a wide diversity of microbes. Like you'd put a range of fibers in there that you can see a number of things go up. There might be some, and I put pomegranate in this category actually, where you tend to get increase in bifidobacteria. So there are like a much more standardized response to it. You get decreased levels of pathogenic bacteria, increased B rate producing species, increased bifidobacteria is something we see with pomegranate house congestion. So it's like that to me would fit that. But I think it would be a different scenario if we were talking around other types of polyphenols that would feed other species like Slackia or Gordonibacter or others, which are very important polyphenol transformative species, but we're not sure exactly their broader role in health enough to say, yeah, that would be defined as a prebiotic. But I'm being a bit nitpicky with definition.
Okay, did I get distracted, or I just want to make sure we completed this part of the story of how these flavonoids and how the elagitannins are then being converted by the gut microbiome, and how this then influences mitochondria. Did you complete?
Yeah, no, we didn't quite get there. We got to the conversion spot. So the polyphenols reach the colon, they're consumed and they're absorbed. So in the case of L-tannins, for example, from pomegranate or other foods, some people, not everybody, converts it to urolithin A, and I think that is one with the most research on, because there's also a B variety, and some people it doesn't get converted through, depending on what species are actually present. And this is the nuanced bit of everyone's microbiome being completely unique, and unlike anybody others, is that some people will have different sort of pathways through which that will go through, depending on the rate of or number of bacteria that are present. But I think we can also work to encourage that too. Like I think there was one study I read that initially at baseline, 12% of people produced the A variant, but then after ingestion for a while was actually up to 40% of people were. And I think the research suggests with urolithin A, it's and other things, like if you just eat polyphenols consistently daily for long enough, you will encourage the species that are there in lower numbers to become more prominent. So you might not be a urolithin A producer now, but you might be after 6 months of consumption. That's a possibility too, and particularly those people that don't make either urolithin when it comes to elagitannin. That's my experience, and I've tried to delve into, can we use other prebiotics to help that, and that's an interesting conception that I think hasn't been delved into too much detail yet. But we need to define what species actually consume the compound, and we can work out or essentially convert the L-tannin into urolithin A. What species do that? I mean, some research is suggesting it's a bug called Gordonibacter as being particularly important in this. So it's like, how do we encourage that? Well, we don't know, besides feeding these tannins that it likes eating,
right?
Which is kind of like, you encourage them if they're there. If you give them food, they will grow, and that comes the same with B rate producing species too. It's like they're there, you feed them, their populations go up. If you don't feed them, they go down. It's sort of like keeping a pet fish or something. If you don't feed it, it will eventually die, and if you feed it, it will grow. It's the concept is pretty similar with our gut bacteria. It's just some bacteria are pretty diverse with their food sources, others less so. And Gordonibacter, I think, is pretty diverse with its source of polyphenols. So it wouldn't have to be only that one. I think if you're eating a wide variety, you probably have a better chance, like a predominantly plant-based, lots of polyphenol, lots of colorful foods, your chance of having Gordonibacter there is far greater than someone eating McDonald's and Kentucky Fried Chicken daily.
Yeah, the circular sort of bidirectional nature of the body in this regard is always fascinating to me. And I grew up as an athlete and in the bodybuilding space. So my background in health wasn't just theoretical. It wasn't just studying concepts. It was self-experimentation. So the idea is like, it's amazing how obvious and sort of common sense it is for people who have that background in self-experimentation, but who only study this in theory. It's not necessarily obvious. But for me, it's like, someone saying, well, how do I get my biceps stronger so that I can lift weights? It's like, well, you practice lifting weights.
Yeah.
so that it's stimulated to grow stronger. And the same is true here. If you want to grow more of those species that do a particular thing, you got to feed them the thing that those species like.
Yeah, no, it's very much that way. And I think that's the thing too about being, because some researchers aren't clinicians and they just can't take that final leap sometimes between how do you convert this into something practically and relevant and helpful for people. And I often think it's too early to even do that, where it's like, okay, well, no, we can just feed those bugs up and their populations will go up.
Right.
And they should get that benefit. Yeah. And I think one of the cool things about that urolithin A is its capacity to work as a mitophagy inducer. And because I think there's a lot of other polyphenols that seem to be good at enhancing biogenesis or the creation of more mitochondria, which is obviously really important too. But I think what's really cool is looking at the research around this, the capacity of those dysfunctional, not particularly well energy producing mitochondria that are just slightly chugging along. Well, we can induce them to die by taking this and be replaced by a proper, well-functioning mitochondria, and then you get all the flow-on benefits that come from that. So I think that's exciting that we're teasing those things out, because I think we would have looked at epidemiological studies would have shown that people that are eating lots of polyphenol-rich foods have got lower rates of neurodegenerative diseases and cancers and heart disease and all these things. And now we're just kind of teasing out the whys in more detail. And then we can obviously apply it differently too, because people with chronic fatigue syndrome or fibromyalgia or other neurodegenerative conditions that are associated with mitochondrial dysfunction, we're like, okay, well, it's not just improving longevity for eating these polyphenols. It's actually, we can start targeting things, and we can try to target things more specifically by potentially using pomegranate skin as a supplement, for example, or I think they're coming out, or that have come out with the urolithin A as a preformed supplement as a way of trying to, directly target those dysfunctional mitochondria.
Right. Yeah. With the idea that roughly 30% of people they say that they don't have the species. Again, with the nuance of what you just described, that if you consume that for a period of time, maybe you will have the species. But the idea is they say 30% of the people don't have the species to take elagitannins and create urolithin A. Therefore, supplementing directly with urolithin A, this postbiotic, the product of the bacteria, will be beneficial. And there's studies to support, of course, that it is beneficial. I'm actually personally looking to create a supplement formula that has that compound in it, because there's so much positive research around it.
It was exciting delving into that more recently, going, oh, look at that, and I just love it, because I've been prescribing pomegranate as the skin, which is high in these compounds, to thousands of patients over years. And that's the unintended benefit that I had no idea was going on, was actually this urolithin A, at least a decent proportion of these people. Because I think, going back to what we were saying before, if you do not have any Gordonobacter or any of those species, then you can't feed them up. It's just that if they're there in tiny amounts, you can revive that population. And this is what, again, I've worked the last decade doing this.
Oh, your sound cut out.
Levels.
Oh, Jason, can you repeat that? Your sound cut out briefly there.
Oh, yeah. Can you hear me now?
Yeah.
Okay. Yeah, so working with other sort of bacterial populations where it's below detectable level on stool test, you're like, okay, well, let's see if it's extinct or whether it's recoverable. Let's feed it. And that's a clear way of seeing it. And you do a post-test and go, has it actually come up or not? And whether it's extinct. And I think thankfully for a lot of people, these species that we see as below detectable threshold aren't actually extinct. They're just below the capacity of our technology to see. And then if we continually feed and feed and feed, fast forward 2 months or 4 months, oh, look, it's there. And I could say that with things like Akkermansia or Bifidobacter or lactobacilli or different butyrate producing species. I've seen that over the last decade of practice very clearly. And it's going to be the same thing with Gordonobacter too. We have to have a test that can tell us that it's there. And I'd say the shotgun test can do that, and 16S tests can do that. And then you'd go, okay, well, let's eat pomegranate and let's see if we can get you there. And then you might go, okay, no, you're going to be the person who has to take urolithin A in its preformed amount. And then there's always going to be, discussions around the amount that gets there too, versus, how much pomegranate's required to get the same serum levels as, taking a capsule of urolithin A. That'll, be something that needs to be teased out too.
Okay, Dr. Hawrelak, do you have 10 more minutes to spare? I know
I can do 10 more minutes.
Okay. You're going to be a little annoyed with me, but I'm going to ask you a a question or two that I know you could spend 5 or 10 hours answering, and I'm going to ask you to answer it in a few minutes.
Ouch.
So,
Okay, I'll do my best.
let's talk about some practical specifics on how to optimize the microbiome ecosystem, how to reduce levels of LPS, and how to increase levels of, you mentioned already kind of how to, in this case of polyphenols and Hawrelak and I, how to optimize that. Consume more of the polyphenols that feed those microbes that produce those postbiotic metabolites. But how do we reduce levels of LPS? And how do we increase levels of butyrate producing species, which, as you emphasize, is very important?
Yeah, and I think probably the biggest takeaway is eat mostly plants, high fiber, nothing processed, unprocessed whole foods that contain a wide diversity of fiber types and colors of polyphenols. We can do all of that. With a diet like that, you'll feed butyrate producing species, you'll lower LPS producing levels in the gut, and you will have enough polyphenols to nurture those species. That's like the big answer. I think there are some specific things like, with similar ideas here, though, because I mean, one of the key butyrate producing species is Faecalibacterium. It likes eating polyphenols as well, and also fructose oligosaccharides or inulin, which we find in things like onions and garlic, and it also likes eating oligosaccharides in legumes. Yes, we've got legumes, onions, garlic. Other foods that contain fructose oligosaccharides include things like yacon tubers, which are less commonly available but really rich, asparagus, globe artichoke, fusum artichokes are just some of the foods that are quite high in those compounds, which will feed Faecalibacterium. And then you have the resistant starches, which are starches that are resistant to our digestive processes, so they reach the colon intact. And they can actually be consumed by those bugs that have the right machinery to do so. And we tend to get more butyrate being produced as a consequence of that. So resistant starches we find, again, in whole grains that aren't milled really finely. So, like a chunky mill is going to be quite different in terms of a fine mill. You find them high in legumes, and also what we call retrograde starch, which is the cooked and cooled variety. So let's say you bake a potato and you eat it cold the next day, you're going to get a tremendous amount of resistant starch out of it versus eating it or particularly if you compare it to like a boiled potato. Boiled potato, very little resistant starch. Steamed a little bit more. Baked, already if you're eating it hot, you're going to get a decent amount of resistant starch. But if you even let that cool, you get a substantive increase in that. So I will often eat cooked and cooled rice, for example. Eat rice the second day, you'll get more resistant starch. Those sort of refried beans, you'll get, particularly if you don't heat them up too much just a second go, you'll get more resistant starch in them too. So we can, there's broader principles of what to eat, but then there's specific things, tricks we can do to enhance resistant starch capacity and encourage a greater amount of butyrate to be produced in the gut.
Okay, I have to ask this. There's always the latest dietary fad trends that are emerging, and there's the low fat, there's the low carb, there's the vegan, and there's the paleo, and there's the keto, and now we're in a trend where the opposite of vegan has emerged. I think at this point, all foods everything other than water has been demonized by one group or another.
Concur. Yes.
and so we've got everything from veganism, that all animal foods are trying to kill you, to the opposite, that literally there are diet gurus now claiming that hey, animals can run away from you. That's their defense mechanism. But plants, they can't run away. So what they evolved these plant toxins, which are really poisons that are designed to make anything consuming them ill. And therefore, all these polyphenols and phytochemicals and things of this nature are really plant toxins that are trying to kill us. And therefore, they're bad. And therefore, you should avoid plants and eat mostly or nothing but meat. From the perspective of being one of the leading gut microbiome experts in the world and having spent decades evaluating that literature, what is your take on those claims and that dietary approach as far as the gut microbiome?
From a gut microbiome perspective, it is, how should I put it? Immensely detrimental might be a nice way of saying it. It comes back to, what are you feeding? What are you not feeding? So if all you're eating is meat and fat, what do you feed in the microbe world? Microbes that are eating protein and bile. All right. And if you look at the metabolic byproducts of those ones, and they tend to be gram-negative bacteria, number one. Two, you tend to have blooms in proteobacteria on that diet. Number two, three, blooms in hydrogen sulfide gas producers, specifically because they eat amino acids and they eat bile. So they're gorging. They're not having a great time of it. And hydrogen sulfide gas causes gut leakiness as well. And in large amounts can be a mitochondrial toxin too. We know in small amounts it's actually good for us, but it just in large amount is really problematic. And that diet just encourages overgrowth of those species. And then the people that I mentioned before that with like low levels of B-rate producers, those are people following diets like that. Like I had one woman who's just eating chicken, nothing else. And her beta producers were 2%. And I was even like somewhat thankful there was any there at all, to be honest. And maybe she just had chicken for the last 6 months, only meat. Because I think based on animal research, you can eventually starve them out to extinction, and then you can't bring them back bar a fecal transplant. Yeah. And certainly patients I've seen post-carnivore, similar type diets where it's been almost no plant foods, their ecosystem is so low in fiber consumers and so low in butyrate producers and so high in pathogenic bacteria and those sort of negative pathobionts that I mentioned before. So it's certainly not from a mitochondrial perspective, like it's not butyrate being produced at all, not even remotely enough for your colon cells even, let alone for anything, systemic benefits that might come from it. And you're flooding yourself with endotoxin. And we know that particularly saturated fat from lard or butter or ghee or animal products, because sometimes they'll drink heaps of cow's milk too, and those kind of diets, which I find interesting too, theoretically speaking, of the rationale for it. But anyway, we know the saturated fat binds endotoxin and increases its absorption. That is very clear from the data. So not only are you encouraging an environment that's full of bacteria, full of endotoxin, you're encouraging its absorption into your bloodstream at the same time with that dietary approach. Because what stops endotoxin being absorbed is fiber. Polyphenols, that's clear. We've got data showing that. We can give people a McDonald's breakfast meal and their bloodstream fills up with endotoxin. But if they take some fruit with that McDonald's meal, they don't get that flood of endotoxin as a consequence. So we can very clearly show that it's the fruit, food compounds, the polyphenols, the fibers that bind to endotoxins and help prevent them being absorbed even when they are there in the gut, whereas saturated fat encourages their absorption through. So, and those patients that have followed that diet for any length of time are by far the hardest ones to get better. And I want to put that out there because I think in the short term, you can have a reduction of gas-related symptoms of bloating and distension. There can be some.
That's what I wanted to say, because there are a number of anecdotal stories you hear from people who I think generally are starting with a lot of dysbiosis in a lot of bad ecosystem. When they then follow recommendations like the ones you're giving to eat more plant foods and a bigger diversity of plant foods and fibers, they feel bloating, they feel gas, they have pain, they have diarrhea, they have problems. Then they might try a carnivore diet, they get rid of all the plant foods, they feel better, they get rid of all those GI symptoms, and then they conclude, this must be the healthy approach, this must be the best human diet.
Yeah, and that's exactly what happens in that situation. But I just know that it does reduce symptoms for some of these people in the short term. It does, but having seen people over the longer term, because all you're doing is increasing hydrogen sulfide gas production, which actually worsens nerve inflammation in your gut. Yeah, so it gets worse and worse. And this woman that was just like eating a couple of chickens, like she tried to go back onto fiber after a few months off. And the things she used to tolerate, she did not tolerate now, because even the tiniest amount of intestinal gas being produced, because that's the thing, protein putrefaction doesn't produce much in the way of hydrogen gas. So you don't get much bulk that comes with it. And any of the hydrogen gas gets shunted to hydrogen sulfide gas production due to all the amino acids and sulfur from the bile that's around in that lumen. That any hydrogen gas gets shunted away. And hydrogen's a big bulky gas, So not much is produced anyway through protein putrefaction. Then what is produced is shunted to become hydrogen sulfide. So you don't get bloated, you don't get distended from it. And hydrogen sulfide gas can speed up your transit time too. So maybe your constipation goes from this process after the first week or two of your ecosystem adapting. And then all of a sudden you get lots of H2S being produced, which is hydrogen sulfide. Your transit time is better, bloating, dissension's gone, pain's gone. You're like, oh my God, that's fantastic. And symptomatically it is. I wouldn't argue with that. It's just that the negative consequences of that, the moderate to long term, are immense. And the patients that have the hardest time trying to get back are the ones who's essentially done that for long enough that the level of inflammation in the gut is so great. And the level, so the intolerance to anything that produces gas is so great as a consequence. So how do you feed the species that are just hanging in there, the edge of extinction?
Because I just want to emphasize this, because of visceral hypersensitivity, because the nerve cells that sense gas and distension in the intestines become hypersensitive, and therefore those people then become hypersensitive and very reactive to the gas and to the signals that are then produced when they reintroduce the plants and the fiber.
That's right. And most of them had that to a certain degree beforehand. Hence, they developed symptoms if they tried the plant-based diet. It was like, all right, you already got that going on. You might also have slow transit time and high methane levels, which slow down your gut, and a bunch of other things that very dysbiotic gut in a few different ways, that if you came to a good practitioner beforehand, they could probably address those things and you don't have to go down that path. But in this case, they have. And you're right. It essentially that hydrogen sulfide gas worsens and worsens and worsens that visceral hypersensitivity. So it gets excruciating at the point where they have a small bit of plant food, they get excruciating pain. So it's really hard to come back, and it's hard to feed their butyrate producers when there's 2% or 1%, and the other healthful species from that. And I do think at some point they will go extinct from that process too.
I'm grateful for the extra time that you took to spend with me here. I want to be respectful of your time. Are there any final words that you want to leave people with? And maybe final piece of advice is, I know you gave a lot of nutrition advice. I know that from learning from you in other contexts and having conversations with you, you also talk about other lifestyle elements and other dimensions beyond nutrition that influence the microbiome. Anything else you want to mention to wrap up?
Well, I think the key takeaway, if I can give one, is love your microbiome. I think that is key, and work to nurture those cells as you would a loved one or a pet. I think people often take better care of their pet than they do, and partly that's ignorance because they don't know how important it is or how to do it. But I think it's trying to shift that narrative, going, those microbes are immensely important to you and your health, and I think just keeping that in mind when making any kind of dietary decision or lifestyle decision or medication decision, is imperative for you in your long-term health. I was just reading some research on antibiotics, and they're looking at cognitive function, and they found that 2 months of cumulative antibiotic use in your 50s essentially aged your brain by 3 to 4 years. Wow. And I just thought that was fascinating, just showing how we, and yes, there's a time and place where antibiotics are necessary. I totally agree, but so many people are popping them for viral infection and just trying them out. Let's try an antibiotic because what else to do. There are consequences from a microbiome perspective, and there are consequences that flow on from that, because antibiotics are also seen as mitochondrial toxins too, because what are mitochondria? Essentially, they evolved bits of bacteria have joined with us. So so I think people being aware of those things too when it comes to medication choices too, that sometimes there's a choice. You don't need to take an antibiotic for viral infection, the yes for a life-threatening bacterial infection, no doubt, but just keeping that in mind too, of always putting the importance of the microbiota at the forefront of your health decisions.
Thank you so much, Dr. Hawrelak, and let people know where they can follow your work or get in touch with you if they want to work with you.
Me let you know.
What's that?
Sorry, do you want me to let you know, or you let them know?
No, you let people know where they can follow your work or get in touch with you if they want to work with you and as a patient of yours. Yeah,
so I got a few different areas, but I'm a clinician via Gould's Natural Medicine in Hobart, Australia. But I do see virtually patients from all over the world, and I run courses both through my Probiotic Advisor site, where we have essentially a lot of material around optimizing the microbiota and using probiotics appropriately in an evidence-based manner, and through my new site, the Microbiome Restoration Center as well, where we're teaching clinicians to essentially optimize the microbiota and to treat gastrointestinal conditions with the microbiome at the forefront. There's always choices. It's like you can treat path A will damage your microbiota, path B won't. And we're essentially going through a range of gut conditions, very similar to the course that you did, and trying to focus on, we can treat this, but in a way that actually is gut friendly and prioritizes the health of the microbiota so you get the best long-term health outcome out of it, and your microbiota stays healthy through the treatment approach that we're doing.
Beautiful. Thank you so much for doing this, my friend. It is always a pleasure chatting with you. I always come out with new layers of knowledge, and I really appreciate your time and you sharing your wisdom with our audience.
You're welcome. Always a pleasure chatting to you too, Hari.
Hey there, this is Ari again. Thank you so much for listening to this episode. I hope you enjoyed it. If you did, if you found it valuable, please share it with your friends, share it with your family, help me get the word out there. Also, if you're on YouTube, make sure to hit the subscribe button and hit that little bell to get notifications every time we release a new video or new episode of the podcast. And if you're listening to this, make sure to subscribe to this podcast on iTunes or on your favorite podcast app. Thanks so much for supporting my work at the Energy Blueprint. I hope you enjoyed this episode. I will see you in the next